Hi, and welcome to this video about Concept 13, which is about solving for y in literal equations. This starts off with a quick investigation. Go ahead and press pause and simplify each of these expressions. What did you notice is the same about these expressions? What is different? Are these two expressions equal? So again, we're talking about A and B here. What's the same? What's different? And are they in fact equal? Let's take a look at this together now. In example A, this expression has one fraction with an expression in the numerator, which we must simplify first. So we have to ask ourselves, what is 9 plus 18? 9 plus 18 is 27, so that's our new numerator of the fraction with the denominator of 3 on the bottom. Then we have a division problem. Fractions are a division problem. 27 divided by 3 is 9. So this expression simplified is 9. Now if we take a look at expression B, we have two fractions, which are two division problems. I'll start by simplifying the one on the left first. 9 divided by 3, top divided by bottom, is 3. And then bringing everything else down, just to show my work one step at a time. Now we have another division problem, which is more powerful doing this addition, so we must do that division first. We have 18 divided by 3. 18 divided by 3 is 6, and we bring everything else down. And now we have 3 plus 6, which is 9. So are these expressions equal? Well, is 9 equal to 9? In fact, yes, it is. So these are equal. What you may have noticed is the same or different about these expressions is that they had the same numbers, 9 and 9, 18 and 18, and 3 and 3, but written slightly differently. If you imagine the expression in A being split up into two fractions, 9 divided by 3 and 18 divided by 3, that's what you would have seen in B. This structure in the expressions are important because this is in fact a rule that is always true. Anytime you have two numbers being added and then divided in a fraction, that is absolutely equal to each of those numbers being divided by the number underneath. This is also true if we had negative numbers, so this sign can be addition or subtraction. Okay, so this is a rule that is always true. You can try it with any numbers you like. And it's an important rule for when we solve these special type of literal equations that we call solving for y. Somewhat of a spoiler alert because this is a topic that you'll see a lot more in a later unit. But we want to get used to practicing this skill while we're looking at literal equations in this unit. You may have heard of this before, so perhaps it's not a spoiler, but when x and y are the only variables in the equation, it is a special type of equation. So this special type of equation is what we see in example 1, and in these equations we're often asked to solve for y. So that means that we're asking ourselves, well, what variable do we care about since there is both an x and a y variable? But it's just the y that we care about, so we might bold that number. And then we have to move other things away in order to get that variable alone on that side of the equation. So what's in the way of y being alone is this 10x and this plus 5. One of these is a constant and one is a coefficient. We always start by eliminating the constant first. So which of these is the constant? 10x is the constant because it's being added to 5y, and 5 is multiplying y, which makes 5 the coefficient. To eliminate the constant, we use its additive inverse on both sides of the equation. That means that on the left side, these are canceled out because they are additive inverses, and we bring down positive 5y. No need to bring down the positive sign because it's implied. And on the right side, we have 20 minus 10x. What do we get on the right side of the equation? Because these are not like terms, we cannot combine them. So we can bring them down just the way they are, 20 minus 10x. Although if you wrote negative 10x plus 20, that would also be correct. Either one of these is fine because of a certain property. Do you remember what property says it's okay to switch the order here? This is called the commutative property. And it's okay if you wrote it this way, but we have to proceed with the problem, so we're going to keep going with the one way that we wrote it here. But keep in mind that either way would be okay. So we eliminated the constant, excuse me, and we noticed that they were not like terms on the right side of the equation, so we had to bring them down without combining them. On the left, we still have this coefficient of 5 written next to y, showing that it's multiplying. So to undo the multiplication, we're going to divide by 5 on both sides. Notice that when we divide the whole side, the entire expression on the right, by that number. Now 5 divided by 5 is 1, which means that this cancels out. And on the left, we're left with just y. Now on the right, it's technically correct to bring down things the way that we have them written currently, but we just learned a special rule, which we're going to use here, which says that we can divide 20 by 5 and negative 10x by 5, and that these are equivalent to the expression we had above. Then we can simplify each of these, because 20 divided by 5 gives us 4. I'm going to write down 4. Minus, and this is 10 divided by 5, which is 2. And there's still an x there, which we bring down. Now you may remember that we can't add or subtract things that are not like terms, but in this case, because we're using division, we are allowed to divide that 10 and 5, and we just bring down the variable x. So this is our final answer. We have now solved for y because we got y by itself. If you wrote your answer as y equals negative 2x plus 4, that would also be valid. That would be what follows from the process if you put the x term in front before. Some of you may have seen things like this before. So if you like to have the x term in front, that is totally fine. Just keep in mind that either way is fine based on the commutative property. So you have a few more examples in your packet. There's not too much that's new here, except that we're going to always simplify completely with these special equations. And again, simplifying completely means using that new step that we just learned, where we split that fraction into two fractions and simplify those answers. Try examples 2 and 3 on your own tonight, and please do not go ahead yet to 4 and 5. Those are ones that we will look at in class. And email or write down if you have any questions. Thank you.